Okay, I'd like to continue with the declarations that we had before. We've got this class, we've called it a node. We've got this thing called these linked lists. And I want to do something a little bit clever here. Your book has done something similar to it. Let me open up another screen here. And I've got it. And I would like to add something to this public class linked list. And notice that what we had here is we had a method that was called insert front. I want to have another method in here, and basically what I want to do is I want to call it public node. Whoops. Let me get things correct here. There, I think I have it. Public a node, and I'm going to call it delete front. So the idea being that if I have a linked list that looks like this, and I call delete front, basically what I want to do is I want to return a reference to this node here, and I would want to update front so that it would now point over there. And there are a couple of situations I want to think about here. That one's one of them. The other situation is what should happen if the list only has one element in it. And then also, what about the situation where it's an empty list? So I'm going to come over here and I'm going to say a node, and I'm going to call it ret node, and I'm going to set it equal to front. Okay, and then what I need to do is I'm just going to come over here and I'm going to check if this thing is null or not. So if front doesn't equal null, okay, then what I am going to do is I am going to say front is equal to front dot get next. Okay, so let's think about a couple of things here. And I hope the garbage truck outside my window is not destroying the video here. Let's consider what happens over here, and I'm going to come over here and I'm going to say return ret node. And notice I've left some space here. Suppose I'm in this situation right over here. So if I'm in this situation right over here, this is going to be the value I'm going to return. And I'm saying if front doesn't equal null, let front equal front.get next. So I have done this one, and this case seems to work okay. What if I'm in the situation like this? And again, ret node would be front, so ret node would return a reference to that right over there. If front doesn't equal null, well, it doesn't. Let front equal front.get next. So the result of that is when I'm all done, it would look like that. And if I come over here, let's suppose I'm in the empty situation right over here, and I have a node, ret node is equal to front, so it's equal to null, okay? And then I come over here and I just say, let's return it, it's returning null. I think this takes care of all the situations right over here. Okay, I think we're all set. So why did I want to do this? Why did I want to put in a delete front? And the answer is really simple. If I've got a public a node delete front and I've got insert front, I would suggest it's easy to implement a dynamic stack. Okay, first of all, remember what dynamic means. Dynamic means that this thing, we don't ahead of time say how big it's going to be. And remember what a stack is. A stack is one of these last in, first out data structures. Okay, so basically, how would we implement push? And push would just be insert front. And how would I implement pop? And that would just be delete front. And there's my dynamic stack. How easy was that? Easy. Okay, we like easy. Okay, now let's do something a little bit different. Actually, I want to extend on this. Your author declares something that he calls a double-ended list. And what a double-ended list is it looks like this. There is something called front. There is something called back. And we have a situation that looks something like this. And then this one comes all the way over here. And it looks like that. So there is something that points at the front, there is something that points at the back. And he talks about implementing a couple of methods here. He talks about insert front. He talks about delete front. And then he also talks about what's called insert back. So what we need to do is we need to implement these, and we're going to see it's not too much different than what we've already done. The point is I want to say that once these are done, then what we could do is we could actually implement a dynamic queue. And the question is, how do you do that? And it's very simple. The push would be insert back, and the pop would be delete front. How cool is that? Okay, so our job right now is to just write these three methods right over here. Okay, so let's continue along here. A couple of things to say about these double-ended lists. We're not going to write all the code, but we'll get enough done. The first one is the constructor, and that's going to be pretty simple. So if we hit public, and we'll call it, suppose we're defining something that's called double-ended. What we have to do is we just have to set these both equal to null. So remember that. And now what I want to do is I do want to talk about, suppose I was going to do public void insert front a node new node. Now what I want to do, and I want to draw some pictures, very fond of pictures. And I want to consider a couple of situations here. Now the situations I'm going to consider, first of all, there's one situation where the list is empty. Like that. There's another situation I can think of where front where there's just one element in the list. And finally, there's the situation something like this. And here's back. And back is way back over there, like that. So I've got these three situations. And I'm going to think about what is the code here. So there is this, there's new node over here. And certainly in this situation over here, what I need to do is I need to set this pointer here to be the same thing as that, as front. So I need to do new node dot set next to front. And then the other thing I need to do is I need to set front to new node. And that would insert that in this here. The question is does this code over here, does it work in this situation as well? Well, if I've got some new node here, and I say new node that's set next to front, so that would set this to point at this thing here. And then I say front is new node, so this would point over to here. And it seems to me that it works in that case too. So it works here and it works here. The only problem I have to worry about is over here. Because what I need to do over here is here I need to say front is equal to new node. And I also need to say back is equal to new node. Okay, so it looks like the following. In all three of these situations, I need to do this. In one situation, I need to do that, and in the other two situations, I need to do that. Well, what are the situations? Well, the situation is front is equal to null. By the way, note that if front is equal to null, back's got to be equal to null. So we could go on either condition. So what I'm going to do, I'm going to bring this over to here. Okay, and I am going to say if front equal null, then what do I need to do? I need to say back is equal to new node. Else, I need to do this one over here. Do node dot set next to front. And then finally what I need to do is I need to say front equals new node. Okay, so I'm going to say over here, empty list. Okay, and that is my public void insert front. All right, so now let me get a couple of more blank slides here to work with. Here's what I want to do now. I want to consider deleting from the front. That isn't how you spell delete. What I want to do is I want to consider what are the possibilities. Well, I could have front is null, and I could have that back is null. I could have front and here's back. In other words, there's just a single node. I could have front something like this, and here's back. Are there any other situations I need to think about? I don't know. What about this? All right. I think I have 4 situations here I want to think about. First of all, this one over here, we just want to return null. There's something I want you to notice. If front is equal to null, then back has to be null. And if back is null, then front is null. This is your empty list. So the test that we can have for this over here could either be if front is null or back is null. But let's come over here, because this is going to be the general case. And in the general case, what I'm going to want to do is I'm going to have something like the following. I'm going to have the return node is equal to front, and front is equal to front.getNext. And then I'm going to do it. Then I would return the ret node. Okay, that's basically this code right over here would cover this situation over here. What would happen in this situation over here? So let me just check that off. In this situation right over here, ret node is front. Yes, I do want to return this reference here. And I say front is equal to front.getNext. So now front is pointing over here. And then I would return the node. So you know something? This code right over here also works in this situation. I'm not sure why I worried about it, but nothing wrong with worrying about things. What's going to happen in this situation over here? Well, if I say ret node is equal to front, so I'm going to return this, and front is going to equal front.getNext. So front is going to set to null. I have one more thing I need to do here. The one more thing I need to do here, I'm going to call all of this, why don't I just call that A? So what I need to do in this situation over here is I need to do A, but I also somehow need to set back equal to null as well. Everybody see that? In this situation here, I need to do all of this, but I also need to set back equal to null, because what's going to happen is when I delete this, okay, I've got an empty list. And in this situation over here, I don't want to do anything. I just want to return null. Okay, so let's see if we can put this all together into something that kind of makes sense. So I'm going to say over here, public A node delete front. And I'm going to come over here and I'm going to say A node ret node equals front. Why don't I do that right away? Now, these 3 cases over here would correspond to the situation that front doesn't equal null. So I'm starting to think that maybe over here I want to say if front doesn't equal null. Um, let's think about that a little bit. So if I come over here and I say if front doesn't equal null, I got a bunch of stuff to do here. Well, let's go back and look at this stuff. Over here, I've already let the rut node be front, so I don't need this line over here anymore. It seems that I need to do this. I need to say front is equal to front.getNext. And then I find myself in one of two situations. At this point, either front is null, which would be this case over here, or front isn't null, and I'm in these two cases over here. I'm going to come over here and I'm going to say the following. If front is equal to null, which means I'm in this case over here, then I need to set back equal to null. Else, what? Am I done? Maybe I am. Do I even need this over here? Let's think about this for a second. So, if I come over here, so if front doesn't equal null, I'm going to do these things. Let's think about this now. So if front doesn't equal null, I'm in one of these three situations over here. And I'm saying let front equal front.getNext. So in one case, front is over here. In the next case, back is not changing. So if front is equal to null, I need to change back. I think this is all I need to do here. Okay. Then what do I need to do down here? I need to return ret node. Wow, easier than I thought. Let's go through these cases again. If it's an empty list, if front, now remember, I have it initialized. If it's an empty list, ret node would be null. If front doesn't equal null, well, it is null, and I would be returning null. This situation's okay. I'm going to come over here to the second situation right over here. So the ret node is pointing at this very first node. If front doesn't equal null, now I'm setting front over to here. Front is equal to front.getNext. And I say at this point, if this is equal to null, I have to set back equal to null. This situation's taken care of here. I'm going to come over here now, consider this situation here. Ret node is referencing this first node. If front doesn't equal null, front is moved up to here. If front equals null, well, it doesn't, so I'm just going to leave back alone, and I return ret node, everything's fine, and that also covers this. So here is my final version of delete front. Actually, much simpler than I thought when we started it. Okay, we have just one more method to write. Okay, finally, the last thing we want to do is insert in the back and we've got some a node, new node. And what I want to do is I want to consider the various pictures for this. So first of all, there is the possibility of an empty list. There is the possibility of just a single element in the list, or the list might be quite large. So this tends to be the easiest case, at least it has been on the other two. So let's consider what's going on here. Now, first of all, remember, we've got some node over here that's called new node. And it seems to me that if I want to insert this into this list in the back, basically what I want to do is I want to change this reference right over here to point at this thing right over here. Now remember, our constructor always makes this reference null. Well, this looks really easy. So I think I just need to say back.setNext to my new node. Okay, I think that will insert that one over here, and that takes care of that one. If I come over here, again, that seems like this line over here is going to take this one pretty easily. Here in the empty list, what do I need to do? I need to set front and back both equal to new node. This is going to be really easy. Public void insert back. A node, new node. And I just come in here and I could say something like the following. If front equal null, let front equal new node, let back equal new node. Else back.setNext to what? I think the new node. Yeah. And that's it. That one was easy. Okay, the rest of the other methods that one would have for this double-ended list are just like for the singly linked list. You'd have a find, you'd have a delete. It's these insertions and deletions that are kind of interesting. Write it up, type it in, have some fun.